So I'd like to begin by introducing our keynote speaker for the morning. Our keynote speaker is Larry Peterson from ON.Lab. Larry is perhaps one of the most influential computer systems and networking researchers. He has an impeccable record. He has been the director for multiple conferences. He is, for more than a decade, led the PlanetLab Consortium. And if you came to the workshop this morning, that PlanetLab Consortium was responsible for the underlying mechanisms that Rick was showing folks, Rick and team were showing folks, for being able to allocate those Genie experiment engine slices. There are thousands of researchers worldwide have used PlanetLab. It's one of the most widely used pieces of software. Larry Peterson chaired the committee that got Genie started. So you can tell what a kind of a seminal researcher we have. He's currently working on some advanced virtualization techniques and operating systems at ON.Lab. You heard in my keynote yesterday that I believe that virtualization is a very important future direction for our infrastructure. And with that, I'd like to make sure you know he's also a member of the National Academy of Engineering, a fellow of the Association for Computing Machinery and the IEEE, the 2010 recipient of the IEEE Kobayashi Computer and Communication Award. He received his PhD from Purdue. Please welcome Larry Peterson.
Thanks. Thank you, Glenn. So you've got context in your head, which is PlanetLab and Genie. And so I want to ask you to momentarily suspend that context. I'm going to talk about OpenCloud. It's drawn a lot of lessons from PlanetLab, and it's drawn a lot of lessons from Genie, but it's something different. It's a project that's we're undertaking as part of the Open Networking Lab, which you may know is an offshoot from Stanford. Nick McHugh and Scott Shanker from Berkeley, and Guru, who's in the back here, are part of it. It's related to SDN, it's related to the cloud, but it's a new idea, it's a new thing. So I'm going to try to give you a little context for what OpenCloud is and give you a sense of what we're trying to accomplish and what we're trying to do. So I'll start with the 10,000-foot picture. OpenCloud, in our mind, is part of the cloud ecosystem. It's not a test bed that sits off in a laboratory. It is one of many clouds. Amazon's got a cloud, Google's got a cloud. There are lots of private clouds. Think of OpenCloud as one of those clouds that you can access in the cloud ecosystem. Now, it doesn't float above the other clouds. It's very tightly integrated with those clouds. And that's because of technology that we envision flowing between OpenCloud and the underlying systems. That arrow goes in both directions, and that's pretty important. As you might guess, OpenCloud is about creating new technology and hoping that that technology influences the commodity in private clouds out there. So that's the downward flow of the technology arrow. But there's an upward flow as well. There's an awful lot of industry out there and a lot of money being spent to build cloud technology. As you know, the more researchy academic side of the world, we can't ignore that and just go off and try to reinvent our own copy of the cloud. We need to incorporate as much of that technology as possible. So it's part of the cloud ecosystem. We're going to aggressively include new technology in it. And we're going to have some very targeted customers or users that we're going to go after that we don't think are being served by today's clouds. So let me just walk through that list. So I'm going to start with the most obvious, which are the cloud innovators. I could have said researchers, but I want to think more broadly. There's a lot of innovation going on out there, some of it academic, some of it not quite so academic. These are the folks that would like access at a very low level to the cutting-edge technology. So just as an illustrative example, certainly anything related to SDN end-to-end is something we want to make available to those users. But it's not just those people creating new technology and creating new cloud architectures and new services and so on. We also are targeting actual cloud users, and this is critically important. It doesn't make any sense to build new technology if you don't also have someone to try that technology out. So in that sense, it's very much in the spirit of what US Ignite is doing. It's a living laboratory, right? It's connected by technology, and it's connected by users to the cloud infrastructure, or the cloud ecosystem. And finally, it's targeted at cloud providers. These are the people out there representing the public and private clouds down below, but we wanted to think of them not only as a target for the innovation, but they are users of OpenCloud, in the sense that they have new solutions they have solutions they're looking for. They will come to OpenCloud, we believe, to do showcases and proofs of concepts of those new technologies as they solve and address their particular needs. Okay, part of the cloud ecosystem, it's not a standalone laboratory, it's a living laboratory, it is out there and it's deployed. So if you have the audacity to believe that you can create a new cloud, clearly you need to take a look around because there's a lot of work that's been done in this area. And so an obvious place to start is what can we learn from Amazon? So this is the console, if you haven't been there recently, at Amazon AWS. And what you'll notice here, I think, is just a little tiny corner of what Amazon offers you is EC2. Quite often we think of Amazon's cloud as EC2, but that's just a little tiny corner of what we get from Amazon. The lessons we take away from this is that it's all about the services. That's a long list of services. There's monitoring services, there's database services, there's file services. The list goes on and on. It's about the services, it's not just about the infrastructure. The infrastructure is only the very preliminary starting point. It's about the services you can deliver on the cloud. Lesson number 2 is that it takes a coherent, comprehensive architecture to build something like that. And I'm going to add to that open, because what we want to do is to enable a large community, a larger set of innovators to innovate on a service-oriented cloud in the same way that Amazon has. Now, if you go to Amazon, it might very well be the case that you would find out that there's an awful lot of brittleness underneath that, because they sort of came to this pretty picture through a lot of hard experiences, a lot of hard work, and anyone that's worked with an evolving system knows that you don't necessarily have the best architecture at the end of the day. From what we understand from even this advanced community is there's a need for a cleaner architecture here. So that's what we're setting out to do, is to build an architecture around the idea of providing services, not just infrastructure. We have a 3-part approach, and it sort of goes from the abstract to the more concrete. At the top, at the most abstract level, we have an architectural principle which is very simply stated that everything is a service. All right? I'm going to use the acronym XaaS, XaaS. Everything is a service. And if you start thinking about that as the organizing principle, then it takes you in a direction you might not have gone if you didn't start there. So it's critical you start projected in the right direction. We have a manifestation of that principle in some software. The XaaS operating system, XOS. That's going to be open source. That's open source software. You can go get the pilot version of it right now. And it is a cloud management system, if you want to think about that way, to manage resources. Finally, we have an actual deployment of that. We have operationalized, or in the process of operationalizing that software to stand up a cloud. And that was the previous picture. OpenCloud is a running operational cloud running that software. You can run your own private version if you want as well, but there will be an operational version. And it will be interesting because it will expose you to technology you wouldn't have otherwise been exposed to if you'd gone to a commodity cloud. If you could have gone to Amazon to get everything we're offering, you should have gone to Amazon. It's already there. So let's drill down a little bit. I'm going to go through those 3 layers, just spend a few minutes on each one. If we start at the top, everything is a service. Well, there's 3 things people are talking about, especially in industry right now. The cloud, obviously. SDN, software-defined networking, and NFV. If you may not have heard that, that's network function virtualization, but it's the latest rage in the telco industry. And what these are about, the cloud is simply about demonstrating best practice. It just simply demonstrates the best practice in scaling functions. The cloud is a scaling machine. That's what it does. It scales. That's what it brings to computing. SDN treats the network control plane as a function, as a programmable function. NFV treats the network's data plane as a programmable function. You see where this is going. We're turning the entire network into a programmable function. Cloud technology teaches us how to scale that function. So the cloud is about scaling functionality, and this is true whether the function is a consumer application, an enterprise solution, a telco service, whatever it is, whatever layer of the stack you thought it was, it's just a service. Well, what is that's a pretty vague, abstract concept. So what is a service? Well, it's a very clean picture. I think it's all about separating interface from implementation. So a service has a controller and a set of instances. Those are the instances are how you scale it up. The controller is that logically centralized interface to network-wide functionality. We need to stop thinking in terms of interfaces to devices and start thinking of interfaces to network-wide functionality. It has many points of implementation. Now, implementation you thought was software, but when you get to the cloud, implementation is software plus how you scale it. And those instances are then scaled across the network. So this is true whether you're talking about network as a service and the instances are OpenFlow switches. You're talking about compute as a service and the instances are virtual machines. You're talking about a higher level concept like a content delivery network and the instances are caches. Or you're talking about security as a service and the instances are firewalls. The same principle applies. We need to think in terms of a service controller giving us access to network-wide functionality. That's the interface. The implementation is how it scales. Well, scaling clearly is a key here. So this is just a sort of a cartoon version of what the cloud looks like in my mind. It has data centers, but it has also points of presence in the middle of the network, in the routing centers and all the way out to the edges, to the central offices, to the wireless edges, connecting you to the devices and the enterprises at the edge. So when you think about scaling a function, the first thing you think about is scaling in the data center, but that's how you scale cycles. That's how you scale computation, because there's such a density of cycles in the data center. But it's also the case that you scale functions at the edge. So this, I think, is consistent with what Lynn was talking about yesterday with Locavore, that you move things to the edge. And you scale functions to the edge because it gives you better latency to the edge, but it also gives you aggregate bandwidth. And that's bandwidth that you can't get back in the data center. You get orders of magnitude more bandwidth at the edge than you get back even at a very well-connected data center. So now the problem is, how do I take my function and distribute it across the entirety of the network from the data center all the way to the edge? That's the real challenge, virtual machine placement and the virtual networks that connect those. Well, just before I drill down into a little bit more about how we're going to achieve this, the reason you do this and you start thinking about services as the first-class object of your cloud is it allows you to start thinking about service composition. So one service, the blue service, is a set of virtual machines connected by one virtual network. The red service is another set of virtual machines connected by another virtual network. And of course, they get embedded in the physical network. That's the compile step. That's the optimization step. Functionally, they are two separate services, and we can connect them to build new things. Well, this isn't just an abstract idea. We have a running example of a composition called Syndicate, which is a scalable storage server that's built by composing a CDN, an object store, and a NoSQL database. The CDN gets you scalable read bandwidth, and here we have taken advantage of some Akamai caching technology. Those are services that we've composed then, actually two services, with an object store, which is what gives us data durability. So we get scalable read bandwidth from the CDN service, we get persistence and durability from a collection of existing cloud storage services, and finally, because sometimes users want to write their data, which invalidates what's in the cache, you need data consistency, and that's a service implemented in Google App Engine. So it's a composition of services to create something brand new. The second thing that you get out of this is the ability to create new platforms more simply. So I think of a platform, and these are custom platforms as a service, as simply a mashup or a script that takes advantage of that pool of services that I've now made available as first-class objects in my cloud. I get a large set of them. They're third-party. They're my own services, wherever they came from. They scale in the cloud, and I can compose them in different combinations, essentially by writing a script. In some cases, it's that simple, and I've created a brand new service. I didn't deploy any instances. They were already, the instances were already part of other services, but I created new functionality that I can present to users. That's the high-level abstraction. Everything is a service. So I want to spend just a couple minutes going down and talking about the software underneath it. The operating system is XOS, and it defines a service as a first-class object. A service is a set of slices. Those are just resource containers. This is the one thing we took from PlanetLab. Actually, there's two things. This is one of two things we took from PlanetLab. We took the name slice. We just liked it. It's the way we represent a resource container. In PlanetLab, it was just a bunch of virtual machines. Here, it's much richer. It is as well, let me finish the service first. Service is a set of slices plus a controller model so that I can control that service, and a controller plugin. I'll show you a little bit how that fits into the architecture in a minute. We give you very flexible control over the operational parameters of those slices then. So a slice is a set of virtual machines plus a set of virtual networks. You can compose the virtual networks so that you can compose the services that they host. Virtual Network 1 composed with Virtual Network 2, which ought to strike you just for a moment as a little bit strange because virtual networks are about isolation, which is true. That's what you get in a multi-tenant data center. But you go the next step and you compose the virtual networks, you concatenate them, you allow for very controlled connect points so that you can compose the services. Otherwise, you have two options. They're either isolated and you can't compose them, or you compose them through the public internet, which gives you absolutely no control over how they're composed. And then finally, you can optimize both of those two parameters, the virtual machines and the virtual networks, defining where they're placed, what image they run, how many cores are allocated to them in the case of virtual machines. In the case of virtual networks, you control the topology, you control the network operating system that controls the virtual network, and you can allocate bandwidth. So you allocate resources in both cases. Where this takes you is that you're now in the business of managing services, not servers. And that's going to lower the barrier to operationalizing new services through composition, and it's going to lower the barrier to creating new customized platforms by leveraging the existing services. So the software architecture at a very high level, XOS is really a cloud management system, if you want to think of it that way, but we're really bringing an operating system mentality to it. That's the glue that holds it all together. Everything you see in orange is the set of services. They could run in OpenCloud's hardware, or they could run in Amazon's hardware. If they export a service interface, they can be incorporated into the model. The green stuff down below are the virtualization technologies. OpenStack is clearly, we're going to leverage to virtualize the clusters. OpenVertex is a network hypervisor. We're building an open networking lab that we're going to use to virtualize the network. We can dynamically create virtual networks that are customizable by running a different network operating system on each one. Real quickly, just in a picture, OpenVertex can hand out different virtual networks with different topologies, each one in their own network operating system. And then it embeds that into the physical network underneath. You can ask for a topology that's a big switch, or you can ask for a topology that's perfectly isomorphic to the physical network if you wanted to. Taking that purple box at the top and blowing it up just a little bit, there's a data model at the middle. We can build different views on top and think of those views as scripts. You're going to see a lot of parallels to Unix here. We got a kernel, and we've got a shell that runs on top of it that we can build different portals or different views for different users. And at the bottom, we have a controller plugin framework, which is where I interact with the service controllers from all the services that I import. Time doesn't permit, but this is where all the hard stuff is, because you've got distributed state to manage. The authoritative state for XOS is in the data model. Each of these services is trying to do its own thing. Keeping that state consistent is the challenge, or is one of the larger challenges. So those services could be arbitrary services, but I want to show you one specific example of what they could be. They could, in fact, be other clouds. So recursively, I'm calling it native OpenCloud. Those are the resources that we have. I'll show you a picture of what those are in just a second. So those will be some of, and that's managed by OpenStack right now. That's the native OpenCloud, but I can give you access to the HP cloud, also OpenStack base. I can give you access to EC2, or you can have your private cloud. So this is going to be a really powerful way of taking your private cloud and then bursting to somebody's public cloud as your demand dictates, and all under the umbrella of a uniform interface. So the value proposition for XOS is it does leverage OpenStack, but if you've ever tried to use OpenStack, you know that that's an extremely challenging thing to do. So here's the second thing we took from PlanetLab: the name slices and experience-based operational model. 10 years of experience in operationalizing distributed virtual machines. This has given us a set of policies and configurations, if you will, models of how the thing works and operates, and that we brought to bear here. It also then makes service a first-class object, gives you end-to-end SDN, and we can bring in these decentralized cloud providers, public and private, a dynamic source of innovative services, i.e., you, the research community, and there is a realistic deployment platform, which I'll show you in just a second. Now, I keep talking about Unix. Service as a first-class object is really an idea that I sort of think of as common abstractions lift all services. And I can kind of, I'm not going to take the time, but you can go through the list of capabilities and features in XOS, and you can identify a Unix counterpart. So composable virtual networks is the mechanism by which commands can be composed together to build using pipes in Unix. Customized platforms are shell scripts. The ability to, on the fly, create new functionality. And I could go on down the list, but I'm going to move on the last couple of minutes. I promised that there was a deployment, and there is. It is currently being deployed throughout Internet 2. We have large clusters at 5 sites, 4 US sites and 1 European site, and servers in the POPs of Internet 2. Internet 2 is an incredibly important partner here. If you go back to that very first slide and I showed you OpenCloud is part of the ecosystem, we want to think of, in a couple of years from now, that in the same way Internet 2 brings the research and education community bandwidth as a service with the Internet 2 connectivity, they will also bring these cloud services as a service to the larger R&E community. There's a web portal. I just draw attention to the fact that it's extensible, so everything that's extended down the left-hand side, left-hand nav bar, are the new services that get brought up and incorporated that you can access. And the extensions across the top-hand set of tabs are the portals or the views that we can make available to different users. And so this particular view happens to be what we call the tenant view because it's the one that looks the most like EC2. You just go to it and say, I would like to have 24 VMs. I'll give you some different sites that you can bring them up on. And oh, by the way, would you please load the genomics database in because I'm going to do some data analysis on it. And you would get that data set loaded in. So that's the quick overview. You can read more about it at opencloud.us. And if you go there, you will also find a link to the demo site that I just showed you. You can log in and kind of poke around with read-only access. So I think I'll stop there, and I don't know if there's time for a few questions.
Let's see. Do we have any questions? So, Larry, I thought that was terrific. When Larry talks about services, services are, of course, what your applications provide. So think about this as an open cloud on which you can implement very flexible applications to provide services in education, healthcare, and so forth that are the hallmarks of US Ignite. I think this is an extremely powerful and really has got some of the cleanest definitional lines, cleanest conceptual lines of any of the things that you may use. I think it fits very well with the kinds of architectures that we're installing and people are doing in US Ignite. So thank you very, very much.
Thanks.
Appreciate that.
Thank you,
Larry.